back to the channel. Today we are going to solve a cool problem from Leetcode called count of interesting subarrays. If you are into algorithm or you are just love solving challenging problems, stick around. We have got an awesome problem to dive into, and this is the today contest question. So let's break down the problem together so that you can fully understand it. And ready, let's go. So I hope you have gone through the statement as we have here, and so let's begin to understand the problem first, right? So we have given an array of integers, right? And we want to count how many subarrays are interesting. But what does interesting mean? So let me explain here. So first of all, we have given nums, right, a list of integers, and modulo an integer, say m. Give me 1 second. And the first we have given nums, a list of integers. Then we have given modulo an integer say m, or modulo you can say, and k another integer that will be greater than equal to 0 and less than modulo. So our job is to count the number of subarrays where the number of element x such that x modulo is equal to k also satisfy count modulo k. Or you can say the if this happens, so it also satisfy this. Any of this will work, but if this any of either this satisfy or this satisfy, right? So we can say that it together satisfy also. Okay, got it? So before looking at the example, let's understand first what is a subarray, right? So subarray is a contiguous sequence of number from the array, like from 3 to 4. If this is an array, what are the subarrays are there? Subarrays can be 3, 3 to 3 to 4, 2, 2, 4 and 4. So these are called subarrays. Okay, so let's look at the example and imagine we have this subarray. Okay, so before going to the subarray, let's understand what makes a subarray interesting. Okay, and then we'll go to the example. So what makes an subarray interesting? So take a subarray, let's any of these subarray that we have taken, right? Any of these. In these subarrays, I'll take a subarray 3, 2. Okay, and count how many numbers in the subarray satisfy. So if nums at I will take, this is a subarray. So nums at I, let's suppose 3 we are talking about, and modulo will be some value will be there, right? So if satisfy equal to k. So let's say this count is CNT count, right? So then subarray interesting only if count modulo is equal to k. So this will satisfy if you take the subarray and if you do the modulo, right, k, modulo, right, nums at I modulo is equal to k. So we can say this count, right, but the subarray is interesting only if it also satisfy this one. So count modulo equal to k, right? So we will filter the subarray by counting how many nums modulo k, modulo equal to k. Then check if the count is modulo again is equal to k, right? So that is called subarray interesting, right? You understand, right? So an interesting subarray is one where the count of numbers nums at I such that nums at I modulo will take equal to k is itself a divisible by modulo. Sound tricky, right? So let's visualize it. Okay, so if you go through the example, there was an example, right? Example 1, and nums is saying that 3 to 4 modulo is 2 and k is 1. So we try all the subarrays, right? So here how we go about it, the first we start every possible subarrays in the array. So these are the subarray 3, 3, 2, 3, 2, 4, 2, 2, 4 and 4, right? So these are the subarrays. Now for each subarray, we check how many numbers satisfy nums at I modulo k, modulo equal to k. If the count of such numbers, if the count of such numbers, let's call it CNT, is divisible by modulo, then we subarray is interesting, right? So we'll take 3 modulo 2 because modulo is 2, equal to k is 1, right? Now here we call this as a if the count of such numbers are there, right? So we say this as a CNT, right? And CNT is 1. We can say CNT is 1, right? Now we'll divide by the modulo, right? Now the CNT count is divisible by modulo, right? And that is equal to 1. So this is called interesting. Similarly, 3 2 is here, only 3 is good, CNT is 1, right? We do these things, it will come interesting. Similar 3 to 4 is there, 3 is good, right? Interesting. Now 2 is there, it is not interesting. 2 4 is there, no, not interesting. 4 is there, not interesting, right? Means there is 3 subarray, there is 3 subarrays, 3 3 2 3 to 4. We found interesting subarrays. I hope you understanding, right? Just this is mathematical terms, so that is a simple modulo, right? We are taking, right? So let's take the first example, right? So for this subarray is 3, right? For this subarray 3, we have taken 3 modulo 2 is equal to 1. So the count is what? 1. So the count is 1. Then we have taken what? 1 modulo 2. It is coming 1. Perfect, right? So this is interesting subarray. Now if we'll talk about 3 2, we still only have one number satisfying num set I modulo 2 is equal to 1, right? That is for 3. That is because of 3. And so this is also become interesting, right? But if you'll talk about 2 4, right, these things, neither of them them satisfy the condition, so those are not interesting subarray, right? So what we can do, the brute force approach or way will become too slow, right? All right. So the brute force approach would involve checking every subarray, counting the number of nums at I modulo will take equal to k elements, and it will verify the count satisfy the condition, right? But trust me, that would be too slow when the array size gets larger. So instead of that brute force route, we can use a more efficient approach based on the prefix sum, right? So if you have already solved the prefix sum problem, it will be easy for you to understand, right? But don't worry, I am here to explain this, right? So let me walk through that, right? So the brute force way, we will try, you can, if you're in interview, you can say we'll try all the subarray, and for each simple element count good elements. I will check the condition, right? So these things we will do, but the complexity will become O of n square, because for the array subarray, what we have to do, we have to go with multiple loops, right? And you have to, I think we have to go for loop 1 2, and let's suppose we left to right, right to left, and then inside from left to right, means 3 nested loops you have to go, right? But still the time complexity become O of n square, that will be too slow for more than thousands, right? You can say square, right? 1 lakh for n is equal to 1 lakh, right? So it will be too slow. Okay, now let's understand the prefix sum based approach, right? So this is a prefix sum approach, and we will use Hashmap also, right? So this optimized way, what we will do in step 1, we'll build a prefix sum, right? So instead of checking every possible subarray, we will track a running count of how many numbers so far satisfying the nums at I modulo equal to k. So we call this the prefix sum, right? So we'll build a prefix sum, right? So instead of counting subarray value again, we will track a running count of how many value up to these points are good, right? And will satisfy this theory, right? nums at I modulo is equal to k. We call this as a prefix is equal to 0. Okay, and as we iterate through the array, we keep a map to track how many times each prefix sum has occurred, right? And that is why we have to take Hashmap. Okay, because as we iterate through the array, we keep a map to track how many times each prefix sum has occurred, right? And so that we have to also use Hashmap. Okay, so for each number, it satisfies nums modulo k that increase prefix. Now we will calculate need prefix minus k plus modulo is called modulo. So this is prefix value we need to have seen before. So we will use a Hashmap frequency to track how many times the prefix sum modulus has occurred so far, and we'll say we will add a prefix sum dot get default value is 0. So the answer will default will have 0 to the answer. So these are how many values subarray at the end at the current index will have, right? And so we will update the frequency with the current prefix. Okay, so here is the key part. For each number in the array, we will calculate the prefix sum. We need to make the subarray interesting, and so the need will become what? Need will become prefix minus k and modulo, and we will take the modulo, that we will get the need, right? So this will become your integer. We'll write int need equal to prefix minus k plus modulo will take, right? And then we'll take modulo. So this need tells us what previous prefix, you can say what previous prefix sum would make the current subarray valid. So the array is where the magic happens instead of checking each subarray. So we look up how many previous prefix sum match this need, right? Means this need, right? This need tell us what previous prefix sum would make the current subarray valid, and there is where and this is where the magic happens instead of checking each subarray. So we'll look up how many previous prefix sum match this need, right? So this is the prefix value we need to have seen before, right? And for that we'll do step 3 and 4. Okay, so let's dive into the problem solution, you can say. And let me go to the code. So this is the code, right? And as you can see here, right, we have taken a Hashmap first of all, right? Frequency, then then what we will do, by default we'll add a prefix sum modulo 0 seen once, right? We'll take a result 0, prefix is 0. For nums, we'll go for all the elements. We'll take modulo of the element equal to k, and we'll call it as a prefix. We'll increase the prefix plus plus. We'll take the modulo of this prefix, right? And we'll find the need, as I told you, right? So prefix minus k plus modulo, and we'll take the modulo, and this will become your need. Once the need is ready, we'll do the frequency of this need, and we'll say result plus, right? So whatever will come, we'll increment the result, and then we'll do prefix update. So prefix will do put on the frequency, and we'll increment the count, right? The frequency will get updated, and finally we'll return the result. Okay, so in this way you can see that modulo we are taking, k we are taking, and we are expected output is coming. Okay, thank you guys, thank you for watching this video. If you really like this video, please hit subscribe this channel, and let me know if you have any doubt in the comment.